This paper is a result of a more complex project which investigates the role of clouds as a link between the solar activity and the inner climate variability. We analyzed correlations between atmospheric oscillations, solar and geomagnetic activity, on the one hand, and tropospheric and stratospheric temperature in the northern hemisphere on the other hand. The dependence of correlations on season, solar activity level, and phase of the quasi-biennial oscillation is also investigated. The existence of some correlations between tropospheric or stratospheric temperatures and internal and external parameters might help in identifying processes that transfer energy from the Sun to different atmospheric layers and in assessing their role in climate variability. Temperature data come from the time series of Sterin from 2004, which are temperature anomaly data based on radiosonde measurements in the northern hemisphere at tropospheric level and stratospheric level. Teleconnections were considered which have hemispheric extent as the Arctic Oscillation or regional extent as the Northern Atlantic Oscillation, the Scandinavian pattern, or the Pacific North American Oscillation. We have also included the Southern Oscillation, taking into account its global impact. Data sources for all teleconnection indices are taken from the NOAA. 3 solar proxies were selected to check possible solar effects on northern hemisphere temperature, the UV irradiance, the geomagnetic activity, and the cosmic rays flux. All time series were then separated according to the phase of QBO, east and west, and to the level of solar activity. All datasets were detrended using a linear square feet, and all calculations were done using detrended data. Significant tests are described in detail in the paper. Correlation coefficients are shown here in terms of color coding, with dark blue meaning relatively strong anticorrelations and deep red showing strong positive correlations. White cells show a lack of significant correlation. The northern hemisphere tropospheric temperature correlates with Pacific North American pattern, Southern Oscillation, and Scandinavian pattern. Surprisingly, the correlation with Northern Atlantic Oscillation is weaker than expected and exists during QBO West and solar minimum. Solar effects at tropospheric level are less clear. A surprising result is the anti-correlation between stratospheric temperature and Southern Oscillation, which is the strongest and most consistent relationship seen in our results. Stratospheric temperatures correlate negatively with the cosmic rays. The most surprising result is the poor correlation between the northern hemisphere stratospheric temperature and UV, which might exist for QBO West and solar maxima at annual level. Consistent results are given in shown table. The tropospheric temperature variability might be influenced by the Pacific North American pattern with positive correlation and by the Scandinavian pattern with negative correlation, especially during cold season, west phase of QBO, and minimum solar activity level. The solar effect at tropospheric level is rather small and seems to be mostly due to cosmic rays. Thus, if existing, the solar modulation of electric atmospheric properties and cloud cover might play an important role in climate and weather. A surprising result is a strong correlation between the stratospheric temperature in the northern hemisphere and the southern oscillation, with no important dependence on season or solar activity level. This might be explained by a transport energy process involving a bottom-up mechanism by which processes triggered by the southern oscillation propagate at higher altitude. The lack of correlation during QBO West suggests that the troposphere-stratosphere coupling is favored during certain phases of the stratospheric wind. In conclusion, tropospheric temperature correlates to external or solar effects during solar maxima, while teleconnection seems to take over during solar minima. The response of stratospheric temperature to both internal and external triggers varies with both solar activity and QBO phase. Correlation with internal parameters maximized during solar minima and QBO east, while correlations with the external parameters are stronger during solar maxima and QBO west.